Hello everyone. Today I am going to giving a presentation on the organic chemistry. My topic is UV visible spectroscopy. Now we will discuss about what is UV visible spectroscopy. Now we discuss about UV visible spectroscopy. As we know, molecular spectroscopy that involves study of the interaction of ultraviolet visible radiations with molecules, that is result of interaction of UV visible light and the molecules. Ultraviolet light and visible light have just the right energy to cause an electronic transition of electron from one filled orbital to another of higher energy unfilled orbital. When a molecule absorbs energy of appropriate wavelength of an electron is promoted to a higher energy molecular orbital, the energy is then an excited state, like pi star to pi star, and double bond changes into single bond. What is the formation you get from UV spectroscopy? The wavelength of absorbed light will provide the information on the energy gap, which is related to the functional group. Like UV visible spectroscopy, possible transition organic molecule, pi to pi star alkanes, mm, pi to pi star unsaturated compounds, sigma to sigma star alkanes, sigma to pi star carbonyls, and to pi star carbonyls, and to sigma star oxygen nitrogen sulfur halogen containing. UV spectra of organic compound are generally collected from 200 to 700 nanometer, like sigma to sigma star alkanes 150 nanometer, sigma to pi star carbonyls 170 nanometer, pi to pi star unsaturated compounds 180 nanometer if conjugated, and to pi star carbonyls 300 nanometer, and to sigma star oxygen nitrogen sulfur halogens 190 nanometer. UV spectral measurement of absorbed radiation. When the diffraction grating, then it emit from slit 1, it contain light source UV, light source visible radiation. Now the light from the slit 2 filter. After filter there is a mirror, then the half mirror, then mirror 2, mirror 3, and there are many systems which is used in this, like simple cuvette, reference cuvette, detector 1, detector 2, lenses. UV visible spectroscopy under absorption law. The first law is Beer-Lambert law. बियर लैम्बर्ट लॉ क्या होता है, हम उसके बारे में डिस्कस करेंगे अब. एट अ गिवन वेवलेंथ एब्जॉर्प्शन इज प्रोपोर्शनल टू द कंसंट्रेशन ऑफ एब्जॉर्बिंग मॉलिक्यूल्स. जो एब्जॉर्प्शन होता है हमारा वो डायरेक्टली प्रोपोर्शनल होता है कंसंट्रेशन, किसकी कंसंट्रेशन के, जो एब्जॉर्बिंग मॉलिक्यूल्स हुए हैं उसकी कंसंट्रेशन के, एंड द पाथ लेंथ ऑफ द स्लिट थ्रू द सैंपल. इसके लिए हमें एक इक्वेशन दी गई है. द इक्वेशन इज A इज इक्वल्स टू ECL. A इज एब्जॉर्प्शन ऑफ द सैंपल विच इज log 10 अपॉन I नोट अपॉन I नोट इज इक्वल्स टू इंटेंसिटी ऑफ द रेडिएशन एंटरिंग द सैंपल. I is the intensity of the radiation emerging from the sample. L is the length of the path through the sample, and C is the concentration of the sample in moles, and I naught is the intensity of radiation entering the sample. I is the intensity of radiation emerging the sample. C is the concentration of the sample in moles per liter. E is the molar absorbability, liter per moles per centimeter or meter per mole centimeter, where M is the mole per liter. M is the molar absorptivity, formerly called the extent coefficient of the compound, is a constant that is characteristic of the compound at a particular wavelength. Now we will discuss about molar absorptivity range. Molar absorptivity may be very large for strongly absorbing compounds, more than 10,000, and very small absorption is weak, like 10 to 100, no absorption give E is equals to 0. Now the absorption law. UV spectroscopy absorption law. Guanosine has a maximum absorption at 275 nanometer. E is equals to 275 is equals to 8400 per mole per centimeter, and the path length is 1 centimeter. Using a spectrometer, you find the now the Guanosine is equals to A is equals to ECl 0.70 is equals to 8400 into 1 into 1 is equals to 8.33 into 10 raised to power 6. Now we will discuss about the presentation of spectra, how we represent the spectra. The ultraviolet visible spectrum is generally recorded as a plot of observance versus wavelength. The choice of the solvent to be used in ultraviolet spectroscopy is quite important. Usually, solvents that do not contain conjugated system are most stable for this purpose. The graph between absorptions and the lambda nm, which is in nanometer, uh, the lambda max is equals to 195, which is transition from pi to pi star, and the lambda maximum is 274, and n from to pi star transition. This is for the acetone whose formula is CH3C double bond O CH3. This is the acetone. Lambda max is the wavelength where maximum absorption occurred. Now we will discuss about chromophore. What is chromophore? A chromophore is the part of a molecule that absorbs UV or visible light. ये एक मोलिक्यूल का पार्ट होता है जो यूवी और विजिबल लाइट्स को एब्जॉर्ब करता है अपने अंदर. Now we will discuss about chromophore in various compounds like alkanes, alcohols, ethyramines, sulfur compounds, alkene, alkynes, carbonyl compound, and another compounds. Alkanes molecule contain a single bond, and the only possible transition are sigma to sigma star absorb ultraviolet energy at very short wavelength below 200 nanometer, shorter than the wavelength that the experimentally accessible. अल्कोहल, ईथर, अमीन्स एंड सल्फर कंपाउंड्स. अब हम इनमें देखेंगे कि क्रोमोफोर की क्या क्या वैल्यूज़ होती हैं. Insaturated molecules that contains atoms bearing non-bonding pairs of electrons, possible transition of the N to sigma star. They are also high energy transition. Alcohols and amines absorbed in the range of 175 to 200 nanometer. Organic thiols and sulfide absorb between 220 to 200 to 220 nanometer. Most of the absorption are below the cutoff points for the common solvents, so they are not absorbed in solution spectra. Now we will discuss the chromophore in alkenes and alkynes. Possible transition from pi to pi star. These transitions are of rather high energy, 170 nanometer as well, but their positions are sensitive to presence of substitution. Now we will discuss about chromophore values in a carbonyl compound. Unsaturated molecules that contains atoms such as oxygen or nitrogen may also undergo N to pi star transition, which is 282 and 290 nanometer. Carbonyl compounds also have a pi to pi star transition at about 180 nanometer. Now we will discuss about the substituent effect. जो UV visible spectroscopy होती है उसमें substituent effect क्या होता है? The attachment of substitution groups in place of hydrogen on a basis of chromophore structure change the position and the intensity of an absorption band of the chromophore. जो अटैचमेंट होती है सब्सटीट्यूएंट ग्रुप्स की किसके साथ इन प्लेस ऑफ हाइड्रोजन ऑन द बेसिस ऑफ क्रोमोफोर स्ट्रक्चर, उनकी पोजीशन चेंज होती है और इंटेंसिटी भी चेंज हो जाती है एब्जॉर्प्शन के साथ साथ. सब्सटीट्यूएंट दैट इंक्रीज द इंटेंसिटी ऑफ द ऑब्जर्प्शन एंड वेवलेंथ आर कॉल्ड एक्सोक्रोम्स. देयर आर 4 टाइप्स ऑफ सब्सटीट्यूएंट: hypochromic, hyperchromic, bathochromic, hypochromic. In general, Substituent may have any of four effects of chromophore: bathochromic effect, red effect, hypochromic effect, hyperchromic effect, hypochromic effect. Now we will discuss about the bathochromic effect, which is also called red effect, a shift to longer to lower energy, and hypsochromic shift, which is blue shift, a shift to shorter to higher energy, and hyperchromic is an effect, the effect which increase the intensity. Hypochromic effect is a effect which decrease the intensity. Now the effect of conjugation on lambda max. Conjugation raises on the energy of HOMO and lower the energy of LUMO. With increase in conjugation, HOMO and LUMO gap will increase. There is an energy gap which is between ethylene, butadiene, hexadriene, oxatrine. Bathochromic effect or red effect, a shift to longer energy will be observed. Now we will discuss about the substituent effect. Oxochrome exert their bathochromic shift by means of extension of the length of conjugated system. Methyl group also produce a bathochromic shift via hyperconjugation. There are some compounds like benzene, phenol, phenoxide ion, aniline, and anilinium ions. Like benzene have lambda max is equals to 255 nanometer, and phenol have 270 nanometer. Phenoxide ion has 287 nanometer, and aniline have 280 nanometer. Anilinium ion has 254 nanometer. These are the some hyperconjugation or bathochromic shift whose values are given. This is the given diagram for the UV spectrometer. Firstly, this is the mirror first, and then is there these are the two sources of light. And firstly the light emits from the slit 1, then it from the diffraction grating, that is slit 2, that is filter, that is our reference beam, reference cuvette, lens 1, this is our detector I note, this is one, and the lens 2, sample cuvette, sample beam, this is mirror 3, this is mirror 2, this is half mirror, and this is mirror 4. Now the uses of some of them. Firstly, the uses of now we discuss about the uses of detectors, which is used between the lenses and the intensities. The detector converts the light from the sample into an electrical signal. Like the light source, it should give a linear response over a wide wavelength range. With low noise and high sensitivity, spectrometers normally contains either a photomultiple tube detector or a photodiode detector. Other specialized detectors are found on high performance systems to improve wavelength, coverage or sensitivity. Each detector has a different sensitivity and wavelength range for system with multiple detectors. The system will switch to the detector correspond to the required wavelength range of the measurements. Now we will discuss about the light sources. These are our light sources. In light sources, the ideal light source would yield a constant intensity overall wavelength with low noise and long-term stability of the output. Unfortunately, such a source does not exist. Two different light sources have historically been used in UV visible spectrometers. The deuterium arc lamp was used to provide a good intensity continuum in the UV region and useful intensity in the visible region. The tungsten halogen lamp yielded good intensity over the entire visible range and part of the UV spectrum. Now we will discuss about the um, Now we will discuss about the reference cuvette. This is our reference cuvette and this is our reference beam. In reference cuvette, UV cuvettes are usually made of quartz or silica to maximize the transmission, like polycarbonate and polyester absorbed in the UV. The reference sample, commonly called a blank, is the same type of cuvette filled with the solvent used to dilute the samples. And the reference cuvette is used to cancel out the absorbance due to the stock solution. Why we use the sample cuvette? This is our sample cuvette. Sample cuvette is used, a cuvette is a type of sample holder for liquid samples. Often they are made of plastic, silicates, glass or quartz. Stellar net offers glass cuvette for experiment in the visible region. Cuvette also comes in 2 or 4 polished sides. Why used filter? After slit 2 we can see about our filter, which is used in this diagram. Filter is used removing or partially removing ultraviolet radiation from the light source. This is the given presentation for the UV visible spectroscopy. Thank you.